In this video, we are going to see about a very important function called exponential function. Exponential functions are of the form y equal to a raised to x. They are used extensively in modeling and solving a wide variety of real-world problems, such as continuous interest, compound interest, population growth, radioactive decay, and numerous other applications. Let us try to graph this function y equal to 2 raised to x. We can easily graph this using our graphing calculator. Since there are several choices given in this question, maybe we can enter that in our graphing calculator, y equal to 2 raised to x, and then we can fix the window where x minimum is -5, maximum is 5 with a scale of 1. Y minimum is 0 to 25 with a scale of 5. And when we graph it and compare the given result, we know that B is the correct answer. We can also find using point-by-point plotting for the function 2 raised to x by using the table values given in our graphing calculator. So in our graphing calculator, when we see, we may have 0 is mapped onto 1, 1 to 2, 2 to 4, 3 to 8, 4 to 16. So those are the points. We can connect that using a smooth curve, and that will represent the equation of the curve y is equal to 2x. There are various properties for exponential function. For a and b to be positive, a not equal to 1, b not equal to 1, and x and y are real. There are three important properties here where the product a raised to x, a raised to y will be the sum of the exponents x plus y. If it is the quotient a raised to x by a raised to y, then that will be the difference a raised to x minus y. A raised to x whole raised to y is going to be a raised to x times y. AB raised to x will be a raised to x, b raised to x. A by b whole raised to x will be a raised to x divided by b raised to x. And the two expressions are equal. A raised to x is a raised to y only when x is equal to y. Or a raised to x equal to b raised to x. If the exponents are equal, then the bases a and b must be one and the same. So these are the several properties of exponential function. Now suppose if we have -2 squared, -2 the whole squared is 4, 2 squared is also 4, and we know that that is true. Now let us see whether this contradicts the given statement. In our property 3, we say that a raised to x would be a raised to b raised to x only when a is b. Here our -2 raised to 2 is 2 raised to 2, whereas -2 is not equal to 2. Then will this contradict our property? No, because in our property, this a raised to x equal to b raised to x only if and only if a equal to b, provided both a and b are positive. A not equal to 1, b not equal to 1. In our case, a is negative, which is -2. So it is not positive, it is not 1. B is positive, b is 2, but b is not equal to 1. So it does not contradict the property. The same way, if I take this equation a raised to -2 equal to a raised to 2, that will be true only when a is 1 or a is -1. If a is 1, we get 1 raised to -2 is 1. 1 raised to +2 is also 1. The same way, -1 raised to -2 is also 1. -1 raised to 2 is also 1. This again does not contradict the given property, say property 2. The a raised to x would be a raised to y only when if x is equal to y. Here x -2 is not equal to 2, but still it is true. Why? Because it doesn't satisfy the original result. A is 1 and B is not equal to 1. Here my A is that result is true only when A is not equal to 1, B is not equal to 1. Here we get A equal to 1 and B A equal to -1. So this result does not contradict the property. In order to understand the exponential regression, let us take a set of values here. We are asked to find a scatter plot and also the exponential model for that by taking 2000 as the base year. If 2000 is the base year, that will be 0. 2004 is 4, and then 8, 12, 16, etc. We can enter that in a graphing calculator under L1 and L2. Just like the regression model, linear regression model and cubical regression model, we can get the regression model using a graphing calculator. So let us select a stat plot and choose the appropriate key to get the scatter plot. And then select a stat calc. In that we try to find the exponential regression where we get y is equal to a times b raised to x, where a values and b values are obtained using a graphing calculator. Entering this under y equals, we can easily graph the curve. So these curves can be used to find the interpolation and extrapolation of any given data. The compound interest, which is a equal to p into 1 plus r by m whole raised to mt, can be obtained using our graphing calculator. First of all, we know that P is the principal value or the present value. A is the amount, which is the future value. R, which is the rate of interest, is always taken in decimals. M, the number of compounding periods per year, can be 1, 2, 12, 24, 52, or 365 according to the period given in our question. T is the time in years. So in a graphing calculator, we can select our apps. Under apps, we select finance. And when we select finance, we get the TMV solver. The TMV solver is n equal to, it is asking for n equals, I equals the rate, principal value, the payment, future value, payment per year, and compounded per year. Without using the graphing calculator, we can also get these values using the algebraic method. The algebraic method will be a little tedious. Using our graphing calculator will be easy. So in order to understand the graphing calculator method, let us take a question. It says 10,000 is deposited into an account with an interest of 7.5% annual rate, and the interest is obtained monthly. It is compounded monthly. We are trying to find the amount at the end of 20 years. So P is 10,000. The rate in decimal is 0.075. Since it is compounded monthly, your M, the period, will be 12. T is 20. So we can enter that in a graphing in the formula. A equals P into 1 plus R by M whole raised to MT. Substitute these values and simplify, get the answer. Or else we can use a graphing calculator. In that, the first one, N, is the total period. Total period every month it is compounded, so 12 per year, like that 20 years. So 12 times 20 will be 240. The interest rate in the calculator, you take this exact percentage, 7.5. The principal value is 10,000, but we are not paying anything extra every month, so the payment is 0. For the time being, take the future value as 0, otherwise you cannot enter the next value. So in the beginning, take that as 0. The payment per year, since it is compounded monthly, the payment per year, the cumulative values per year is 1212. So move your cursor to future value and then press alpha enter. Moving the cursor to the future value and pressing alpha and enter will give you the answer for the future amount. The future amount will be, it will be given as negative. It is going out from the bank, so it is negative $44,608.17, which is the same as the algebraic result what we got. So it is easy to use your graphing calculator to get the compound interest. The continuous compound interest is A equal to P e raised to RT. See the same principal amount with the rate of interest 7.5 if it is compounded continuously for 20 years. Using the formula P is 10,000 e raised to R 0.075 into 20 using a calculator, we get slightly higher than the earlier one. Now this one is $44,816.89. So these are a very good application. The continuous compound interest and the compound interest are very good examples for exponential function. Thank you for listening and thank you for watching. Thank you.